Yo, what's up? I think it's a bit loud, maybe. Like so. Alright, so... Today we're gonna be working on the camera projection view matrix. Rotors, was it, right? I have a guy who is supposed to do that stuff, but he's on vacation right now. So he sent me some resources about it. Hello, Piglink. But I'm not too sure about... I could read about them, right? Or... I could just do implementation with the normal projection view matrix stuff and get it to work there, but... Let's see. Because then I could first make it work with normal Euler rotations, the thing that we're trying to avoid. And then, well, I mean, you still got... We'll see. We'll open up that. And then what we'll do here, let's see. Because what we'll have to do is that we'll have to take in... Now the push constant also will have to take in a actual like... I guess what I used to do is that I had the... Wait, hold on, I think... Was that what I did? CD, projects, legacy... I think I had like the... projection view inside of a structure, and also I had time. I didn't pass time. Well, it doesn't matter really how I used to do stuff. What matters is how I'm going to do it now. GPU scene data. This is what I used to do. Yeah, so I had like GPU scene data, and then in a vertex I stored it inside of this GLS. What was it called? Let's see, it's in here. Was it here? Scene data. I basically stored all of it in here, and then I used the push constant to... Oh, that's just the render matrix I'm at for. So I actually then just put it in set 1 or set 0. Interesting. Because I was thinking of doing... Well, yeah, it kind of makes sense if you think about it. You would have... Because you don't want that in the push constant, right? You want it in the uniform buffer. Because then everything can use the same. And then that you also want to be by frame, so you want that in the frame data. Yes. Okay. Maybe I should do some cleaning before I... No, because it's the... Hello, Tota. So we can actually start by the swap chain, because there we have the frame data already, I think. Frame data here. I used to have this thing, GPU scene buffer. I removed it, but now I think it's becoming relevant, and I guess GPU scene. I think I want to call it something different. Let's see. GPU scene data. Frame data. Well, it's already data in the frame, so frame data GPU scene. Graphics GPU scene. I guess it's a really good name, to be honest. And then what we can do is in here, we can do a const buffer, we'll take it in here as well. And then just in buffer.zig, so we'll have access to it. And then in here, I used to do like this, so I'm gonna take it back. Yeah, we don't really have this thing now. What's this gonna be, this thing? And I guess this is actually just relevant for the swap chain. What? The only thing that it's always going to be relevant if you're trying to access a frame data, right? So I think it's still fine to put it straight in frame data, because it's only at this point it's going to be relevant. If you are using it somewhere else, then you probably are having access also to the swap chain with this information. So I'm going to do it in here. Scene data. Const is equal to structure. And now that we got all our data in there at the top, I'm gonna remove it from here. Like so. So GPU and scene. I think that's fine. And what we're gonna have in here, yeah, we have to make it, is it export? Or extern? Extern. Export for functions, extern for this. And this is just gonna be, what do we need in here? We need a matrix. So 16 of F32s. That's what we're gonna be needing. I'm just gonna call it view projection. Yeah. And we could also actually put in the time in this thing. So then we wouldn't have to do it in hpush constant. I think it would be smarter. So we're gonna change this one to take in time. Probably use an F64, but I'm gonna go with F32 still. Alignment still would be affected here, actually. I didn't think about that. Well, for this small amount it won't really matter. Yeah, well, as long as this is like okay alignment over here. But yeah, I don't want to do view and projection separately. I'm gonna do view projection. I don't care about these things for the moment. I think it's fine like this. So then we're just gonna get size of GPU scene. I still don't like the name. Should I just rename this to frame, perhaps? Swap chain frame nights frame data frame. It is frame data. Okay. So we'll actually just call it frame data and then GPU scene. Oh my god. Oh, size of that. VMA handle hold on, what? We cannot do that anymore. I knew we were gonna get to this. Oh, I have changed it, thank god, so it's a bit cleaner. And then we can just pass in the VMA. And it's gonna be a uniform buffer, usage, VMA, memory usage, CPU to GPU. Yes. VMA allocation create map bits. Don't remember, but yes. Could we perhaps make it also a... No, we don't... Why would we do that? That doesn't make sense. I was thinking of using the buffer address extension for this, but now it's like... So we would take a pointer, and what would be the point of that pointer? We could... The descriptor set is way more convenient here. But yeah, that's what we'll do. We'll do this. So, what the heck? I wonder though, should we perhaps... These are all just pointers, right? So it's yeah, pointer and a... Ah ha 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 ha! Not a pointer. Could do a copy, but the thing I'm just wondering about is actually doing the init in the return. But yeah, because it's a point, it's an actual... Yeah, we're gonna do it in the return. And then we're gonna do this dinit in here. Oh my god, please. And then same for this thing. Save that, and we don't have VMA anymore in past in here, so we'll have to add that. I don't store this VMA in self, no, I don't, and I don't wanna do that. VMA, so, and then we'll go to references. We'll have to change this one to take in VMA, and we still have to pass it in over here. VMA, oh my god. And then this one is called from here. Self dot VMA, there. And that should be it. Of course, we still need to do something about it. The thing is that now we got the thing. So what we'll do, we can quickly, the simplest thing we can do is that we'll remove from the push constant the time, right? Because that's just dumb to pass it in there at the moment. And what we'll do instead, okay, it's gonna complain, that's fine. We'll pass the time now into this uniform buffer, and if we're gonna be using that uniform buffer, we need to create the descriptor layout for it. And that we're gonna do over here, I'm thinking. Yeah, it makes sense here. It's temporary because I want to make this a bit better, because right now I'm making it very hard coded, right? It's just this and nothing else, but of course we want to have a little bit more of... What's the word? Dynamic stuff. I don't know. And I'm just gonna call it layout. And then we're gonna take the layout, descriptor layout, like so. So we have the pipeline layout and descriptor layout. How about that? That's pretty crazy. I think it's pretty crazy. And what we're gonna do, we have these things. This, I should probably make a shaders thing, because this is really ugly to read. I think like shaders.load or something, because I don't want to keep it in here. Kind of like an assets shader.load would be nice. So you would have Vulkan assets folder, maybe that's too deep. Because we also would like to do it for the images and that kind of stuff. Maybe it could also be outside. I think I'm gonna do it right now, because, or actually I'm gonna make it run first one time and then I'm gonna do it, because otherwise if I'm doing the changes now and something breaks, I won't know if it's because of the new implementation or if it's because of, you know. So, and then I should also move these things. Anyways, I'm gonna do self.layout is equal to dot, or try to init. Oh my god. And we're gonna pass in self.device, and here we want to pass in the bindings. Now, this is gonna be funny, because I always do this wrong. We're gonna take this from here, yank that, and then we're gonna go back, and what we're gonna do is do this, then we're gonna do a const lol. Just because the LSP always breaks, I'm gonna do it like this, because it's easier to work with it then. Binding descriptor type, descriptor count, stage lags. And the only thing we're gonna care about is right now getting in a matrix and a time. Actually, we're not even gonna be using the matrix to begin with, but that's fine. It's gonna be binding 0. I should make it an array actually to begin with. because that's basically what I'm gonna do over there anyways. So let's see if I can do this right. I know it's something, you do the equal sign over here, then you do like that, and then you do this over here, and I don't think you do that. Then, yeah, but this is where it's gonna fuck up. I think I'm gonna lose the LSP because of this, yeah. So we still have to do it outside. Hey Doritos bro, what's up? Okay, we're gonna do it outside. My bad. It's okay. Const lol 2. It's fine, you know, it's just a temporary thing. But then I'm gonna put it in there, just to make sure that everything is fine. Recently downloaded new Vim and Lazy, but every time I quit and reopen, the open file is blank and every other file is okay. Why? Even not though I saved them. I'm not sure what you mean. You need to save on exit, right? I don't know if you're saving. You have to do, when you do, you do :Q to exit, and maybe you do an exclamation mark to force exit. But you need to do the W to save, and then you can quit. And if you have lazy Vim, you can also do for all, so you can do A. But yeah, remember W to save. It's really good. It's really good to save your changes. Let's see if my brain can brain. So descriptor count. It's not gonna brain. I think we're actually gonna have to take quite early help from the previous project. But that's okay. City legacy. And I'm gonna open it in here. And oops. We're gonna go into there. And I wonder, where do I actually save? Let's see. Search grep. GPU. Date. Oh, it's in Vulkan. I know it is in Vulkan. There it is. GPU scene data. But where's the descriptor set for this thing? Oh my god, LSP doesn't work. You're joking. That's a fine. That's a fine. Oh. Okay, I think it's probably in the render because it has to be. Oh yeah, but they use. Wait. Render info. Let's go up to the top. Okay, here. Let's see. Layouts. Damn, this is so old, I don't even remember. White image. Error, default, linear sampler. This is where I still didn't have the shader objects. Okay, here I'm doing descriptor layout. Okay. Graphics descriptor layout on the scene data. Here, this is the one I'm interested in. So this is what I want to do, basically. So the binding 0, descriptor count 1, descriptor type uniform buffer. Didn't I want to do? But how does it? Do I just? I'm so confused. Okay. Vulkan descriptor layout. That one I don't want to watch. Read. See. I want to get to the descriptor here, but I can't get that on this, so that's fine. I have to do some documentation on the layout. Layout, come on, or some examples. Wow, look at that. Okay, I think am I maybe not in the right? There's a lot of pages here. 1000 searches. Let's see, maybe descriptor set layout, but I'm just doing descriptors. Oh yeah. Because I'm not using the traditional, I'm not gonna be needing the actual descriptor set, just the layouts is gonna be fine. Yeah, here. It shows me the file text after it prompts me to do something like recover, etc. You still doing low-level Zig stuff? Yeah, I'm still doing that. I don't know. I've been thinking about doing something more in Unity or Unreal Godot, but why? I think I would like to make games though, but it's just it's still. I find it enables me more to do this low-level stuff, right? I think differently than if I were to use an engine. When I use an engine, I try to think too abstract, and I feel like the only way I can do something is by trying to find somebody else who has done the thing, or show how to do something in an engine, and then I'm like, oh well, that's not really what I would like to do. Maybe it's just I'm thinking wrong, probably, but I feel more limited when using an engine, even though it takes a hell of a lot more time to get anything done without an engine, but it's fun. And I find that when I want to do something, I actually have to think like, okay, how is that actually supposed to be accomplished? Reinventing the wheel, basically, you know. I should get more water. But it's fun, I guess. Sometimes not. But it all builds just more knowledge. Binding is the number of the entry and correspondence to a resource of the same binding number in the shader stage. Type to specify which type of resource descriptors count. Number of descriptor contained in the binding accessed in the shader as an array, except for descriptor type is inline uniform block, which case descriptor count is size in bytes of inline uniform block. Is 0, this binding entry is reserved and resource must not be accessed from any stage via this binding within any pipeline using the set layout. Flags member bit shaders stage flag bits, okay. Let's see. I feel like I'm missing something here, but maybe it's... Aren't you supposed to tell something about the offsets and where things are being accessed in the field, or are those for the writes? Oh my god, we'll get to it. As far as I'm concerned right now, this is all we'll have to do. I'm gonna learn Vulkan soon, but I must get good at Neovim before killing myself for pain. Nah, you can use VS Code. I just find that I like the customization you can do with Neovim and feeling that I'm a bit faster with it. Of course, there are still things you can do anything in Neovim that you can do in VS Code and more, but you just have to find the bindings and get used to them, and I'm not. It's gonna take a while, but slowly and surely. Same with Vulkan, you know. You could just do whatever you wanted in a game engine, but I think you can do more with Vulkan. It just takes a lot of time, but that's fine. VK, C, VK, descript. Do I say descriptor type, or let's see, what am I supposed to say in here? Descriptor type, yes. Descriptor type, and then is it uniform buffer that I want? I think that's what I want. Let's see my old one. Yeah, descriptor type uniform buffer, and then I probably just want this in the vertex shader, but it's probably gonna complain that it's not used, or vertex shader stage vertex bit. I think it will complain that, oh, you're just doing vertex shader, but it should be in all stages, needs to have the same kind of binding layout, otherwise it's bad. But I still want to see that error. What is this? Immutable sampler affects initializing of samplers. If descriptor type specifies VK descriptor type sampler. What happened to the music? Or VK descriptor type combined image sampler the type descriptor, then imp immutable can be used to initialize the set immutable sampler. Immutable samplers are permanently bound into the set layout and must not be changed. Updating VK descriptor sample descriptor with immutable sampler is not allowed. And update to... Okay. Well, then we will not do that. This is what I want. So I'm gonna take this from here, put it in there, and then we can get rid of that. Oops, not that. Just this. Okay, let's see. It's not very happy. Yes, okay, because now what we want to do... I could keep it outside, or I can take it with me right now. Like, oh holy shit, what the fuck. Okay, wait. We can do this. I think I can do address of this, like that. And then we'll create another one inside there, and I think this one will require a dot. And then we'll take this information from, whoopsie daisy, that was a bit too much. This information from here and save that. And let's see, we still need to do that. And I did that too much. That's okay. Fat fingers, trust me, that was the problem. Because I have so fat fingers, and it seems like it's fine. It doesn't complain at least. Okay, so we'll have this now. But here is where I'm getting confused, because now I'm initializing this layout, right? This layout will have to be assigned here during the shader stage creation, which I still haven't fixed yet, but it's fine, because I will fix it when I make it more dynamic. Right now it's hard-coded for specific shaders. VS Code is not cool because it's too easy. New cooler, basically driven backwards in a highway with flames. Yeah, yeah, no. I mean, VS Code has a lot of cool plugins, to be honest. Like a very cool UI, a bit too much in my opinion, but I still find it that it's I prefer NeoVim when trying to get as much as possible done in NeoVim. Of course, there's cases when I want to use VS Code. For example, for videos, there's a lot of cool plugins you can do to make more cinematic code or visualization of code in VS Code than in NeoVim, so then I usually open up my code in VS Code, but yeah. Let's see, we're gonna get the layout in here. So pset layouts, oh. Is this the... What is that? Pset layouts is a descriptor set layout. Is that my handle then? Or what is that? Self dot... No, wait, is it self... What am I calling the actual... I do be calling it self dot layout handle, but that is... Yeah, that is what I would like to do. I think I might need an address of. Yes. Yeah, okay, and then pset... Oh no. Set layout count 1. That's a bad way to do it, but that's the way I'm gonna do it. Probably should store it actually in here how many there were. But for now we're gonna do 1, and when it crashes and we do more, we will find out. Yes, I think that should actually run though, because now it should just complain that 1, I'm not doing it for the fragment stage, and 2nd, that I'm actually not binding it. Or I shouldn't be binding it, but you know what I'm trying to say. I hope. Let's see. Nope, daisy. Let's see. No field name, right? We have a few errors on here. Yeah, push constant doesn't have the time anymore. Let's see, now it should be fine. There it is. I should be seeing more. Anyways, don't worry about that, but here we can see... yeah, okay. If set count is not 0, pset layout is not null, pset layout must be valid, pointer set layout count, valid descriptor set handle. Yes. Okay. Has push constant buffer lock range 0, which outside... Don't know what that is about, but that's fine. Here. Vulkan code states that if code type PRV flags does not include shader, create descriptor heap bit extension, and if push constant block is declared in shader, the block must be contained inside the element push constant ranges that matches stages. Wait. That's for the creation of this thing. Interesting. Okay, I may have fucked up something else. Command draw shader was created with set layout count of 0, which doesn't match the bound stages fragment with shader was created with set. Yeah, okay, here's the complaint. So it wants, because the bound stage vertex bit shader was created with set layout count 1, which doesn't match the fragment bit, which was set to 0. So we also need to delete for the fragment. Wow, that's a beautiful triangle, thank you. It wasn't really doing what I was hoping it for do, so which is quite interesting. But yeah, we'll add this to the fragment as well then. Like so. And that should get rid of a lot of those problems, I think. Yeah, look at that. It won't be able to hot reload it because it's gonna crash because we're not freeing all of the memory, but that's fine. With time, right, we cannot do this anymore. That's why we're having other issues. So we're gonna remove time from here, then we're gonna be asking what the hell is time then? Well, time is not gonna be anything except for 1 at the moment. And let's see. Yes. So a little bit less problems. We still have a few to take care of. I'm gonna grab some water. BRB. Yeah. God damn, water is awesome. Okay, let's see. Vulkan spec states if set layout count is not 0 and pset layout is not null, pset layout must be a valid pointer to an array set layout count, valid descriptor set layout handles. Yeah, we do not do that. So now we actually have to tell it what the fuck is this descriptor set that we're talking about. That we have told it that exists, but apparently it doesn't. Let's see, shader, objects. Is there a special way to do it, or do I just bind it normally? I should still memcopy some information to it. I think we can start off by doing that. Well, actually, no. Yes, fuck. Wait. Actually, we can just actually... Yeah. We can open it up in here, Vulkan, and we can see... Actually, it's the renderer we want to be inside. Yeah, my bad. Sorry. We want to look at... Here, not here. Here we do this scene data, right? Copy to allocation. Apparently having the VMA, which is basically just a mem copy. I tried to make it a bit easier, but I think I have made it harder to understand. Because literally what I could just do is what I do here. I have access to this. Vertex buffer, okay, but... Yeah, because it's also just a buffer. I think this should be fine to do as well. But just way simpler than whatever the fuck that is. I don't think I should be needing this. I'm not using it even, no. Legend says that Finnish devs get 50% boost in low-level dev power. I mean, we have Linus Torvalds, right? So... But this is basically the same thing, it's just way more complicated the way I have done it here. I could literally just... Why don't I just do it in the buffer and I have a copy information to buffer? Or copy data. And then you just pass in the data you would want. Well, there's a slight problem, like you still need to be able to say that you would want. Okay, I think I will start off by doing this one a little bit easier, so one wouldn't have to do this mess. Instead, you could just say copy. What should I clone data? Copy data? Something that retrieve data, paste data, and then maybe paste data, and then pass the data you want. Paste, and then provide data, and you do buffer paste, and then you provide the data, rather than buffer copy. Copy, clone, buffer copy, and then you pass the data, and then it will just paste that data into the buffer. Linus is the guy who, though, he prefers CW. C is pretty fire. C is fire. I just use Zig because it gives even more control and it's more explicit. But C is still like it's stable. It's never going away, you know. I would do Pro C if Zig didn't exist, but I feel a strong connection to Zig, so I'm using Zig. Yeah, but you can provide a comp by comp time. You can provide a type, and then we can also provide how much you would like to copy, and then you will just provide the thing, and I think that should be fine. We'll just make a function out of that. It will be a way cleaner thing to look at in the buffer here after the init. Hub function, and we're gonna call it copy, like that. And the copy is gonna take in self, which will be a pointer to at this. So we'll have self inside here. That means self.info that pmap data. I'm just doing it to keep it easier. Then here we'll have the comp time and t for type, which will just be type, and then amount, size. What's your, not size, because size or len could work, but I think amount, because you provide the type that you want and then the amount of those you would like to copy. Now I cannot guarantee that this thing will actually have. I should probably do a assertion to check that you can actually copy this amount into this buffer. But I don't think. Oh wait, the device size, is that actually it? Because then I could use that to just check that what you're trying to do is not something completely dumb. So we can take this, whatever you're trying to do. We get that. This is probably more. Size is equal to. Gonna do that, and this is going to be changed to be t. So size of t, and then multiplied by amount, which I forgot to tell it that I probably want it to be a u size. That makes sense. Amount. Yo, Mr. Lucas, I have been out. It's been a while again. Yo, Breeze, what's up, Breeze? Have you changed your name? I don't remember you being called GD. I see you see he see PC. Yes. But here we will have a size. Is that Zig or C++? It is Zig. I'm using comp time and time. Well, it's kind of the same idea as in C++, right? The templates. Right, we also need to provide the actual data that we're going to be using. Which has to come. I will put it here. So this is the actual data, source data. No, I'm just gonna call it data. And that is of type T. So then we will copy this, and then we will do a std assert. Wait, what? Debug assert? Yes. So size has to be less than or equal to self.info.device. I think, am I wrong to use this thing? I don't think I am. Let's see. Am I wrong? Invokes detect illegal behavior when OK is false. Wait. Unreachable. Okay. Oh. Zig language, yes, it's Zig language. And then we can get the data here. I could do the casting here immediately. Yeah, I think that's smarter. So, and then we don't have that, so we get pointer cast map data. So now we have the mapped, and we would like to do it for the size of elements. And then here we're gonna pass in data, like so. So that will now copy the information over to that mapped address. Pretty fire. Now let's see if this actually works. So instead of doing all of this, I'm gonna comment it out. And then we're gonna do self.vertexBuffer.copy. And then, oh shit, this actually... No. I think this will be fine. So we're gonna pass in the type, which will be vertex. And then we'll pass in the data, which will be vertex array. And then vertex... yeah, because it said amount in this thing over here. Did I not? Wait, the type, the data... I should probably take it by reference. I just realized. And then amount. So how many of these vertex do I want? And let's see, I think it's complaining that, yeah. Can I not do... My bad. I'm getting basic syntax. Holy shit. Okay, there. And then we'll change this one to be an ampersand. Like so. Const... Shit. Come on, I can do this. Okay. What if I do... Okay, wait. What if I do this, and then I pass the first element? I think that's fine. Expected found const. Well, I guess I don't actually want to modify the elements in here, so we could take in a const pointer. Error union ignored. Do I need a try? I don't seem to be doing a try. Okay, so let's see how badly I did this. Uh-oh. Right, because I did the clause there, I might have the logic wrong. Let's first just uncomment this thing. Or uncomment this thing. No, still, okay. Source distinction argument have no len. Right, it's already a pointer. So, wait, what the fuck? Huh? Wait, what? So I really need to make my own better C compiler. Damn. Add 3 more vertices and it will work. So having 9 vertices? That's crazy. thread panic source and destination arguments have no non-equal lengths. I'm actually doing this wrong. Hold on. Let me do an std debug print len, and then I'm gonna provide d, and we're gonna do that, got the new line, and we're gonna provide size. Let's see, 228. It might, that should be fine. Paste CIB, because the size of self info size, they should be exactly the same. 144. Okay, so I'm definitely doing something very dumb here right now. But the amount should be 6. Oh my god, sissy. Yeah, it says 6. Okay, what the hell? Okay, what is the size of T? 48. And 6 times that. Yeah. But I have that in here, which is, could make sense actually. Maybe I'm doing it wrong when I, where do I provide the actuals? I knew it. Oh my god. Yes. So okay. There. Now they're 288. Good. But they're still telling me that source destination argument have non-equal lengths. Maybe I need to... No? Lucas has 3 words, so if you want 9, you use Lucas 0 and Lucas 1, Lucas 2. That's size for 3 words. By the way, watching on 4p, so I have no idea what's on your recording. Lol, damn. What do you mean add 3 vertices? I already have 6 vertices. What the? Let's see, what am I doing wrong here? Let's see. I'm supposed to take in a pointer. Given a pointer to a single item, return a slice of the underlying bytes, preserving pointer attributes. Well, that's not what I'm getting here. I mean, I could do this, but I'm trying to not do that. As bytes should be enough. Going from 0 to 1, 0 to that size. I'm pretty confident that it should work. Source and destination arguments have non-equal lengths. The only way that I can watch without my potato overheating. Damn, that sucks. What am I doing wrong here, really? Because I feel like that should be fine. But apparently it's not. I mean, I could also... Wait, can I not just... If I were to cast this data Okay, I'm gonna change this. I'm gonna call this. No, this one can be called. And then I'm gonna call. Byte data, right? And this will be the same idea, right? We will just do a u8 at ptr. No, what? u8 equals at ptr cast data, like so. Const qualifier. Okay, it can be const. Wait, which way do I do this then? How do I add the const? Ah, it's not like that. Nah. Where do I put the const if I want it still to maintain constant? Const? Yeah. Ah, wait. Yes. And then we do this. And then byte data. And then we'll slice it from 0 to size. Still discards const qualifier. How do I add the const back in? I want it. Okay. I don't know. But then that should be fine, the thing I just did, where it was. I don't know, man, that's weird. Okay, it works. And that's way cleaner. So, that's pretty good. And then we can close that. We can uncomment this thing. And yeah, so it can be equal or less than we cannot have. Okay. Yeah, good. Pass it by reference? This is fine. This is fine. So now I will go to VMA. I don't know why I ever had this thing. It's horrible. Well, I guess, you know, it's okay. We don't have to be perfect in this world most of the time. Sometimes we just do something and then realize there's a better way of doing it, and then we change it and make it better. So now we don't need to do this anymore. We can remove it from here as well. And another thing that we can do is that, because now we got this... I think my brain died. Wait, what? We want the uniform buffer, right? Yeah, those things are created in the swap chain. Okay, that's fine. What we could do, I think we want to still update it on each run. So what we're gonna do is we're gonna copy that during the update. I think we're gonna run into some issues here actually, but let's find out, right? So I wonder where would be the best, because here I say the render, right? Where would be the most convenient place to do this in? I think I would like to do it where I do the push constant, because I feel this is already like kind of like a mess. So we're gonna put it in here with these things. Even though I would preferably like to have it at the top, but we're gonna do it here. And what we're gonna do is, we have access to frame data, I think? No, we don't have. We're gonna get the current frame data. So, wait, no, I do have current frame. Why did I not? Oh, but it's not in here. No! It's okay. Cut that. Okay. Yeah, because the render doesn't take in the current frame. Just take the command buffer, the time. Or we should take in the current frame as well. I think that would be nice. Current frame. And that is just a swap chain frame. I don't... Frame data. Is it not public? Well, yeah, we're gonna make it public now. Because we're gonna be needing also this thing, which is gonna become public. I think I went too far. And then render. Render like so. Okay, there. And then here, current frame, swap chain, dot, we have a comma there, dot, Frame data. How big is it? There's pointer, 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 buffer. We'll take it by reference. And probably a const as well, because we're not. No, we're actually gonna be making modifications to it. So, current frame. We got it in here. Then we can go down here. And here we'll add it. Right. Current frame dot my brain actually died. Because I want this thing. Yeah. And then we'll copy. And here, now we'll provide what is the thing that we're actually gonna be doing, right? Right. So in order to do that, we're gonna have to take I think this has to be a bar. So Lucas always hangs out with girls then. Wait, what's happening? Interesting. Pointer's face red eyes. I cannot see those emojis. How did you draw that crazy conclusion? GPU scene data. Scene underscore data, right? And it's gonna be of, we're gonna get access to swap chain, frame data, GPU scene. That's horrendous. I probably will find a better way of doing that, but for now that will do. But it's very clear, like, what we're talking about. We're talking about the swap chain frame GPU scene, or frame data GPU scene. Don't like that the data is in before that, but it's okay. Time is gonna be equal to time, and projection view is just, well, it's gonna be empty. Am I allowed to do it like that? Whatever. Because if you can access the time, then I'm knowing that I'm doing this right. If you can't access the time, then I'm doing it wrong. Simple, right? Gonna take this, and that's what we're basically gonna be copying over to here. And then let's see. Why is it not giving me anything? God damn it. Oh my god. I'm gonna pass in the actual data and then the amount. So scene data, probably by reference, and then I want one of them. In this case. Like so. So, yeah, that should be it. Let's see, there's a few errors. Render will have to now take in also the after command. What? Which order was it? Yeah, current frame. Current frame. And it's gonna be by ref. Unless it's already a pointer. It is already a point reference. Yeah, I took the address of it, my bad. Let's see what else. It wants the view projection matrix. Can I just tell it to be empty? Nope, I cannot. Well, we can do. I would like to do an identity matrix. And see. I don't have num C here. What the fuck? Const and set is equal to size of, yes, perfect. Const and set is equal to import numc. We do have numc in here, I hope. It's okay. I'm gonna build once, and it should probably recognize it. And set dot nothing. I think it probably doesn't recognize it. Let's check the build. So I'm working inside of the renderer, which is. Oh, it comes from shared. I'm so dumb. I'm so dumb. Oh my god, of course. Then we'll do this. Let's see. I think I have shared somewhere. Shader C. Nope. I don't even have. Okay, that's okay. Shared. Like that. Oh my god, not like that. Shared. Dot and set. There we have it. So Lucas, I made a render using OpenGL. It's a 2D one and I managed to add infinite world gen, but I accidentally got a null pointer, so I got segfault for the whole day. Is that normal? Yes. And I later found out I didn't give the pointer something to point at, so it gave me segfault. Yeah, so I fixed that and it worked. So I crashed out of for the next hours. That's normal. I mean, honestly, like I'm no professional, but nah, I'm not. If wait, let me see. Identity D. That's what I want to do. My bad. So I'm gonna provide an identity matrix into this thing. This will just return an array of, well, identity matrix, and we'll assign it to that. But the programming is pretty much just program more, learn more, take note of what you're doing, kind of. Well, you don't have to take note, but mentally. And I think the best way to just, like, I find it that just try to solve more problems will just get you better. I should probably do more solving problems about the algorithms and these kind of stuff, but I don't. But it's like I find that arrays are like pretty much like they solve all of the, well, not all of the problems, but most of the problems that I need something to get done. You can of course go in more in depth on graph theory and these kind of stuff, but I find that that's just overkill for most of the problems that I want to solve. I'm like, a normal array is fine. I'm not gonna be doing something crazy. But probably I'm just not doing too complicated stuff, right? One day, right? We'll get to it. We'll get to it eventually. But yeah, what the fuck? It's projection, not whatever the fuck I was typing. Oh my days. Projection, like so. Okay. Now, in theory, that should be it, I think. Okay. Amazing. No crash. There's just create shader, invalid descriptor set layout object. Right. I haven't yet bound it. That's right. I still need to actually tell it that, hey, use this thing. Which I do over here somewhere, probably, most likely. It should just be a descriptor set bind here. I think that's it, right? So we're gonna do C, VK, command, is it bind? Descriptor sets 2. What's the difference between 1 and 2? Oh. Probably should utilize 2. It looks way cleaner. Let's look into that. Vulkan bind. I can probably just copy it. It's gonna be faster. Binds the descriptor sets to command buffer. To bind descriptor set command buffer, call command buffer p descriptor set info. Also, you provide a info structure. What was the old one? Oh, god damn! Getting flashbang just like that, that's crazy. Okay, and this one is just bind point, the layout, first set, descriptor set count. I'm assuming that this thing probably just, you have like this info thing, which is, they probably have it mentioned already in here somewhere. A link, please? Or do you actually have to do a Google? Oh my god. No? What the fuck? No. I want to know more about this structure, damn it! Okay, because what I'm assuming is that there is like this structure But I now need to provide a pointer to which needs to be an array of them. Maybe it's just easier to use the number 1 in that case. Yeah, let's see. Let's take a look. Let's go in here. And let's see, what does it say? Is it the same thing as that? Yeah, it kinda... No, because there's like... Wait, what the fuck? Yeah, but we don't have descriptor sets. We just have the layouts. Am I doing this wrong? Let's see. Shader object. Shader objects. Layout. Let's see. What can we find on layout? New descriptor set layouts. They just create the shaders with that. Shader. Yes. Talking about the layouts. And place material shader. Pipeline layout shader. Here, command descriptor sets. Yes. So here, this is what I would like to do, this thing. Although it's not always the best to follow a tutorial, but now I'm pretty certain this is the way. Wait, yeah. Yeah, arrays are goated. I use them most of the time. Yeah, okay. And I got a segfault again. Damn, pointers. I just... Too smart. No, 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 no. Don't use smart pointers. Smart pointers make you dumber, okay? That's a... That's a wild statement, alright. No, but I think smart pointers will... Because... You're supposed to know what your code does, right? You're supposed to know how you manage your memory. And I find that smart pointers takes that away from you. Don't use smart pointers. Smart pointers bad. Especially shared pointers are really bad. If you use unique, okay, then I guess it's fine. Not really. Just use raw pointers. It's better, it's superior. Graphics pipeline. And now here I would like to provide my layout, which is pretty much gonna be just self.layout. The one, but I don't have descriptor sets. And that's what I'm trying to avoid to use at all, because I'm thinking, isn't that kind of the point of using the shade, the thing? Wait, let's see. Command buffer, the bind point, VK bind point graphics, yes, pipeline bind point, and then the layout, VK pipeline layout, right, I need to provide the handle. Oh, wait, pipeline layout. I need the pipeline as well? Damn. Wait. Let's read the actual parameters. So the pipeline layout, the first set, the descriptor set count, and then descriptor set. I think I'm pretty sure I read somewhere that with these things, because you shouldn't be needing a descriptor pool. That's what I'm trying to get to right now. Using shader objects, I don't need descriptor sets and pools, right? Sort of no, shader objects do not remove sets or descriptor pools. What? They only replace pipeline objects. Wait, but how do I okay, I thought it actually removed the need for the pools. Maybe I'm wrong then, okay. You're referring to VK extender shader object, which allows using shaders without creating full Vulkan graphics pipeline. Yes. What shader object actually replaces? Pipeline layer created tied to pipeline's pre-compiled pipeline combinations. Instead of binding shader individually, But you still need descriptor system for GPU resources, sets, layout, pools. Is it descriptor heap that I'm mixing up with? Descriptor buffer. The extension removes the need for descriptor sets and descriptor pools by letting the shaders read descriptor directly from GPU buffer. Changes traditional Vulkan the resource binding, descriptor pool, descriptor set, bind descriptor shaders. With descriptor buffers, descriptor data stored in GPU buffer, bind descriptor buffer shader index descriptor. Wait. Bind descriptor buffer shader. Okay. How to bind works instead. Instead of binding sets, you bind descriptor buffer. Bind descriptor buffer offset. Descriptor live in normal GPU buffer you manage. Conceptual example, old way. Allocate descriptor set, update descriptor set, bind descriptor set. Write new way. Write descriptor structure into new GPU buffer. Bind the buffer set offset. The shader access them by index or offset. Why engines refer this? Modern engines like to is it because it gives. What's up? What's up, D-Chef? Bind the resource, no descriptor pool management, much lower CPU overhead, easier multi-threading, large descriptor arrays. It's very similar to directs. Okay. So modern minimum Vulkan stack, modern engines. So I have shader up there. I have descriptor. No, wait, I don't have a descriptor. It was descriptor sets. What about descriptor heap? About descriptor heap. Vulkan does not introduce descriptor heap object. No, but oh my god, I'm so. Okay, let's look into this thing. I think I have it though. Let's see, we can go to renderer. What do I do? I do have descriptor buffer extension. Wait, so is it working with the dynamic render extended dynamic state extension? So wait, this one introduces both the pointer to. So you can provide the pointer and then you can index it inside of the shaders, but you can now also just use. Oh my god. Wait. This is perfect, if this is what I'm thinking it is. VK bind descriptor buffer, command buffer, buffer count, and then you will have this thing, and then set, okay, buffer pipeline bind point, the layout, first set, buffer indices. I'm not sure what that is.
Buffer indices?
Because I'm trying to not use the descriptor set and descriptor pool, because that's just a hell to trying to manage, and apparently there is these descriptor buffers where you can just not do that. We will just live on the GPU that thing, and you can just copy that or move that around. Wait. Never mind, I don't understand how to use them. The smart pointers are not hard to get to know how to use, but I just don't recommend trying to learn them. Because use raw pointers. It's my opinion, of course. You can do whatever you want, but
What?
Breeze is asking in the livestream chat about using smart pointers, right?
In C++.
Yeah, I assume. I'm making that assumption because does any other language have smart pointers? Well, I guess you can make your own smart pointers in any language if you wanted to. But yeah, I would say they are pretty bad to use because they kind of, you stop thinking about memory management you abstract it more. Because you should be pretty clear about who owns what memory. You shouldn't like let you. I mean, you can do that pretty well by just using raw pointers, right?
Look, like I'm so washed with small pointers. Like, I don't know.
What do you mean washed with smart pointers?
Like I didn't know. Like I didn't use them like in 1.5 years.
Yeah, no, they are, but they're like they're not. They are really simple, but I think most modern
Yeah, I know, but
modern C++ platforms kind of demand you to use them.
yeah.
But I'm thinking they pretty bad. Yeah. I think the worst thing is with smart pointers is the shared pointer in C++, because that I really feel like you are not clear on who owns the memory when you start using those things, right? Like you shouldn't get into such a situation. I'm no professional programmer, but that just as a like I you can see on my code base that I write like I'm not good, but Jesus Christ, like when you get to there, I'm like that it's not clear anymore. But yeah, I want to do this thing. So what we're gonna do is we're gonna change it out real quick. We're gonna in here. We're gonna do these things now. And we'll probably have to create that structure. We're gonna have to create that structure. It's okay. We're gonna do C, and then we're gonna take the structure.
C.
Yeah. Yeah. We have been talking a little bit of C during this stream already. Pretty fire.
Oh,
yeah.
About what?
Yeah, basically just that. Well, you know the usual stuff that if I were to use anything else but Zig, I would be using C. No doubt about it. Can I call it info? Is info okay? Address? What is this address supposed to be? I need an example on how to use this thing. Let's close a lot of these things. So it's like Lucas and Tishiv are the girl like a shared. Wait, what? So it's like Lucas and Tishiv are with a girl like a shared pointer. So the situation is messed up because you don't know who owns. Come on, man. No, but what I mean when you do memory management, right? You have this. If you start creating objects, and now you start, then you have this one block of memory here, which you say, okay, I'm gonna put it. It's gonna be shared between. Well, it's not really that bad, but it's kind of like if all of these three now have the same shared memory, like this, and then you deinitialize one, and then you deinitialize this one, then you initialize another one, and they all live kind of like as long as one of these red ones are alive. This memory will exist, and it's like you should have.
That's kind of a point of C++, you know, like Avengers use C, bro, like, you know.
Yeah, but that's the thing where I find it so just. That's why I dislike C++ overall, because it forces you to kind of. No, it doesn't force you to, but it's easy to fall into these traps where you just have these things to always live with objects, when you could just have this thing live here once. And then these things refer to it instead. You wouldn't have this mess over here, bruh. You know, fuck that. And then these objects would just be created or structured sort of an array. And then they could just all use this thing over here. And it would be clear, because then you know that you wouldn't have to worry about anything weird happening over here, because as long as this thing is alive, this one dictates that this thing happens here and now and nothing else. And then you can create whatever you want back and forth with these things. Everything is chill. And then when you close the program, this thing makes sure that that thing is gone. And then, but then the problem is that now in C++ you have 5 of these again, and which all share this thing. It's like, no, stop, stop,
Stop, wait a minute.
stop, just stop. It's just a monster. It's just a monster to deal with. You don't know where anything is. There's pointers going everywhere and scatter around memory and what is it called? Memory fragmentation going on like crazy.
I can't say Gig say stuff to it because I haven't used it enough to give feedback.
Nah, I've used C++ also just for a couple of years, but I live on my own experience and then also just reading from other people who have been using it for more than 10 years. So, yeah. And I also kind of know from, I know, like, when you develop stuff in C, you can still, like, implement, or C or Zig, you can implement, like, these object-oriented IDEs. Also from other object-oriented programming languages like Java. Well, that one has a garbage collector, so you won't really have to worry about it too much. But still, you easily fall into these traps, I feel like, when you try to do something object oriented. Every time, like it's bad. I never used smart pointers because I don't know how. I never learned about them. So basically, Lucas and teacher sharing a girl and it becomes a mess. So the girl is gone. She's dead. Nah. But C++.
Yeah, war pointers are better, bro. Bro.
Yeah, we like our girls raw. That's the takeaway.
What's smart pointer then?
Smart pointer.
I know smart pointer is because you have a girl, but then you
Have they updated the page? Oh wait, that's because I have this thing. Bruh. Oh, they're flashbang. Congratulations, guys. Here.
Documentation in dark mode.
I will send this in the YouTube chat. Weak pointers. I don't remember those, but they have some. You can see here. Weak pointers. This section is incomplete. What? No way. But yeah, just they're actually not that hard. You can literally just see any. They show like the main idea there, and then you can see unique pointers. They show a bit of an example.
So unique pointer just freeze it automatically.
Let's see. A unique pointer is just like it's how should I? Because of RI, you know, resource is initialization. No, resource acquisition is initialization. So meaning constructors and deconstructors in C++, right?
Yeah.
So because if you initialize some,
just freeze it on this constructor. Basically.
Yeah. So you initialize it here with the unique pointer, and as soon as it goes out of scope, it will also destroy the thing that you created. Right? You don't have to call delete on it. You just create it in the beginning of the scope, and then you have it, and then because when you exit the scope, it will trigger the deconstructor, and deconstructor will take care of freeing the thing for you. But again, these things get super like yeah. It's like if you use this thing, then you're not supposed to access the raw pointer, because what if you then exit the scope and then you have a reference to the raw pointer somewhere, and it's just like, just make it damn clear about who owns the damn thing, and then because now you're relying on the deconstructor and the constructor of this thing, and that's why I dislike a lot. It is a fancy thing, to be honest. Like, you can use C++ constructor and deconstructor for debugging purposes, like also profiling. Like, you just create this thing when you go in scope, and it will automatically call, like, it will tag the time when it gets created, the profiler, and then when you go out of scope, it will deconstruct itself and measure how long it took to perform the thing within this scope. But yeah. Sorry. It's still no. Not my cup of tea. And unsmart pointers. Okay, I'm gonna use the unique pointers because I'm lazy just for the damn shaders. I mean, honestly, like, if you still want to get a job, I think you just have to use these things. I think that's just a fact. I can't deny it. Because they're used in every code phase. That's just how it is.
Right, the world is so evil.
Yeah.
Like, in a perfect world, we all would just program C, I swear.
Yes.
So just imagine how perfect the world would be. Nah.
Exactly, you get me.
No JavaScript, no anything.
I actually read, today I finished another research paper on dynamic system updating. And it was written in 2020. And I was thinking, like, with like hot reloading and this stuff, right? It makes a lot of sense for me to think like bytecode, right? There it would make perfect sense, because then you should be able to just rewrite the code and it will just reread it next time it gets into the loop. So yeah, it would make perfect sense. And then also it should work relatively well with servers and JavaScript. But apparently this is 6 years ago now apparently, so back then at least it wasn't really well established. So I have to do a little bit of more research on that. And then I got more errors. Yeah, it's a linker. C++ linker errors. That's not funny.
Yeah. Exactly. Like, I guess linker errors are like free though.
Yeah. Wait, device address. Is this just the same way? I have to now get the actual device address for this thing. I don't want to do that. I don't want to get the device address. But I guess I will have to do it. I should actually include this in the buffer, because now this is becoming quite repetitive. Let's just get it to work first, and then we'll include it in the buffer because, yeah, I'm a bit of a stupid. We'll write to do make getter for buffered device address info short. And we're gonna change it here because hello, who this?
It's the original thread, bro. It's the process root. It's the init process.
Oh, no way. Current frame C in buffer. Gonna get. So we just copied in from speak. Actually, we shouldn't even have to be doing this every frame. We should just do this once, because the address will never move. So this should still be persistent. But, you know. Yeah, this is really bad, because now I'm gonna be calling GPU address twice. I'm gonna call it GPU scene data. It's really ugly, but address probably. But it's fine. It's fine. We're gonna change this in a bit. I just want to see it work once first, and then we will change it. P next. I think that I can just leave it to be null. Well, then I don't have to specify it.
Please make it full screen.
Okay.
Ice type. What is this?
Close it and then you click on it.
Structure.
Oh, smart.
Type.
Smart pointer, bro. Smart pointer.
You guys talking about smart pointer?
Nah. The music is fire though, bro. Like, it's for real fire.
Finding info extension. And what else do I have? Usage. Do I want to provide? What kind of usage do I want? Just read, but I don't know what to say. Usage. Here. There must be no more than max sampler descriptor buffer and descriptor buffer containing a sample descriptor bound, such as buffer must be created with sampler resource descriptor. There must be no more than buffer contain. Okay, so what I'm trying to find is something with CVK buffer usage, and then here the storage buffer. What am I trying to find here? Resource. I think it's probably resource. Let's see what else does exist over here. Transform uniform buffer. Maybe. Vertex, index. This is just a... well... yeah, I'm gonna go with that. If it's wrong, it's wrong. But I have a feeling that it's not wrong. Okay, we got the thing. Now what we should be able to do... we should be able to just call the thing that I'm reading about somewhere. Ah, the flashbang is real again. So C... I think it was somewhere on this thing. Here. Bind descriptor buffer and then set the offset. I think that's it. VK command. Bind descriptor buffer extension. Yes, this is what I want. CIB. No, CIB. And then we're gonna provide a command. And then the buffer count, I'm gonna provide 1. I hope that's correct. And then the address of info, like so. It's probably gonna complain that... wait, what the fuck? Oh, reader declaration, I cannot call it info twice. And I cannot call that one info either. I'm actually gonna do the most horrifying thing I could do. I'm gonna call it info1. And then I'm gonna call this one info2, but it's okay. This is just temporary to see that things works out. And then see VK command set descriptor buffer offset extension CIB. We're gonna provide a command pipeline bind CVK, what's it called, pipeline bind point graphics. And then we're gonna provide the layout, self.layout, .handle. Then first set is 0, I think. Count is 1. Buffer indices, what the fuck is that? I thought that was the thing I just created, but now no idea what is this buffer indices. Why did I even create this thing if I'm not even gonna... what the fuck? What? Why did I create this thing? Oh wait, it's passed in there. Oh, okay, I'm stupid. Okay, great. Let's find out what this is. Great, it's not there. Okay, I might cry a little bit. Let's see, what does it say in here? First set count. To use binding stored in buffer bound at p buffer indices at an offset of p offset for subsequent bound. Can I just pass null if I don't really know what I'm doing? I will pass null. I will just pass null because I have no idea what I'm doing. So we'll go null, and it will complain pretty hard if this is bad. Okay. Not okay. Why is there an error? Expected. What did you expect here? Pipeline layout found set. Oh, pipeline layout. Ah, still want a pipeline layout? Jesus Christ. We'll do that. We do have the pipeline over here. So... Right, now we will also have to take in the sets. How can we make this smart? Let's see. I think there is probably a way how we could make this really smart. Like, I'm talking big brain. Let's see. I could probably
What is
just...
even happening?
We could take in descriptors at layout, and then we'll have to store the count as well in here, because otherwise now it's starting to get really weird. Layout count. Well, it's already a layout. Why would I do that? Count. It's dumb as fuck. Count use size like so, and then we'll always have access to this thing. Brah. Comma.
Okay, right, Lucas, we will be back in 5 minutes. I gotta show something to Fred.
Yeah, that's fine.
Yeah.
Like so. So now we'll have access to the count. So I used a unique pointer in render.h as a global variable, and render.h is everywhere, aka 4 files, so I had 4 copies of the shader pointer, and the linker gave a blob of error that I can't read. But wait, that should... No, it should... If you put it in a global... Do you mean in a class render.h? Because, wait... If you put it as a global, it shouldn't... Maybe I'm just dumb, but I feel like that should be compiled as one thing then. So you shouldn't have 4 instances of it, you should just have one. And now Clang is yelling at me, this is a sign that this is enough coding for today. Like, it's not in a class. But if you have it as a global, I'm pretty sure you should also just have it once in the... Yeah, I'm pretty sure. Maybe I'm wrong. But yeah, if I do pipeline layout, I'm gonna have to take this one after. Like this. Because we wanna pass... We're gonna take it in over here as a parameter. Push constant, and then we're gonna pass in also we're gonna have to take in device const, and I'm gonna call it descriptor at import descriptor.zig. And then we're gonna do here, we're gonna do... What are we gonna... We're gonna call it descriptor layout. And then it's gonna be descriptor layout like so. And then when we create the thing over here, it's gonna be psets layout is equal to, and then we're gonna descriptor... Rather, did I do this? Descriptor descriptor layout, like so, yeah. Jesus Christ, that was hard. Wait, how is it? It's like that. No! Oh my god, whatever. Now I have to type it. The script. It doesn't tell me. And it's also a typo over here, I just realized. This descriptor, like so. And they didn't change it. Damn, this. Like so, descriptor. Gonna yank that, then we're gonna go here. Place it there. Dot handle. And then descriptor count is gonna be script. Why is it not this script? It's just not telling me it. Layout that count like so. I think that is correct, except small problem. This one is probably gonna have to be a pointer. It doesn't tell me now that's a problem, but I'm pretty sure that's gonna be a problem. But yeah, now the pipeline will be created with this descriptor set, or descriptor layout. So we can go back to renderer Vulkan and go down to here, and we're gonna change this to be the pipeline layout. Dot handle, obviously. And there's still a few problems, because in here now we have to pass in self.layout, which I actually would prefer now to be called disk. I'm gonna call it descriptor layout. Alright. Let's see, how far do we go? Not that far. Handle expected, yeah, a const. So we're gonna have to change it slightly. Pipeline here. I'm gonna take the address off. I still think that's not gonna be fine. Expected U-type found use size. Okay, we can change that to use U32 actually. We're not gonna have a use size, but usually I find that Zig uses no. We're gonna have more cases where it's gonna be a U32 rather than a use size.
Guess who is back?
Lucas?
Yes, sir. Smart pointer.
Look at that! That's pretty good. Then we can go to proc these things. We're gonna add the extensions. This is gonna be funny.
What are you doing now?
I'm adding the proc address functions.
But I mean more generally.
I'm trying to work on getting descriptors or descriptor sets, descriptor layouts to the shaders, so we can get the projection view matrix to the shaders, so we can actually render stuff in with a camera. I could do it in the push constant, I wouldn't have to worry about it, but that's just dumb. Right? Let's see, what we're gonna do is that we're gonna go vk command bind descriptor here, and then we're gonna open this thing, and then we're gonna yank it, and then we're gonna go like that, and then we're gonna paste it here, and we're gonna rewrite it slightly. It's gonna be a public var descriptor, and then we're gonna have colon pointer const function. We're gonna remove this thing, and we're gonna have to change this to C. This is just gonna be U32. It's gonna be the same thing, and this has to be a C, and that will be a void, but we cannot forget call convention like last time. Is equal to undefined, like so. Oh my god, what did I just do? Like so. And let's see. Then we can go back to this one, go back to here, go to this one, yank that one, go back to here, paste it there, move it up, and take away that, say var, and then colon pointer const function. And what? C. I should probably just do this for all of the calls, but so I wouldn't have to go and do this. Right, this is gonna be interesting. Whatever. Call convention.c to undefined, like so. And that should be fine.
Lucas, what is your favorite casing? Camel case, snake case, or Pascal case?
I would say Pascal.
Pascal.
Yeah, wait. Let me just check that I'm saying that. Yeah, Pascal case is my favorite.
For types.
Yeah, but also in general, I would like to do Pascal.
Yeah, for real?
Yeah. Which one is yours?
Like right now I'm a snake case more than a snake case fan.
Okay, but in C it makes sense.
Yeah, but yeah, you know, like Cheesecake converted me. I was a camel case function and a Pascal case type guy. But Cheesecake converted me to snake case everything. But now Cheesecake uses Pascal case for everything.
Yeah, Pascal.
But,
Bind descriptor. There. You have to change this to extension. Let's see. Look at that. Buffer was created with buffer use union bit but requires VK buffer shader device address bit. Right, because now we're trying to use it slightly different. We actually have to do that. Because we're trying to use these beautiful extensions. Alright, Breeze has to go. Bye bye, Breeze.
yeah.
Let me think. It's at the top. We have too many buffers. Woo! We're gonna go down here. Whoa! Haha. Let's see. I think it was Control U. No. Oopsie daisy. What does U do? Don't worry about it. It was Control D. Okay, D. And what was it for going up? P? No. O? No, not O. Control D was for down. What the fuck was for up? Completely forgot about it. Anyways, I know I can use this thing as well. What the fuck? No, I cannot. Okay, great. I don't know how to go. Okay, like that. That's crazy. Okay, so we have it somewhere over here. We'll create the buffer. Which buffer am I trying to find? Vertex. Not the vertex one. I'm trying to find the one. Right, where I create a stage. So it's actually in the swap chain, I just realized. In here. It's the Vulkan buffer usage, not the VMA usage. Yeah. It says that it was created with the 2 flag, but I'm not using it with the 2nd flag. Interesting. See that. See, point descriptor buffer extension descriptor buffer feature was not enabled. Book spec states the descriptor buffer feature must enable. I'm pretty sure I have it enabled, but okay, let's see. Can I open this link? Hello? And here's the implementation support, the shader, Future additional function can be enabled in the API, but how do I think this is some...
Yo, Fred, I forgot the exercise I gave you.
I'm trying to find... What am I trying to enable? Sample enable shading. There's too many of them already, let's see.
I will go eat now. Let's talk later about this. Okay.
Okay.
Alright, yeah.
Let's GPT this thing. Because I don't know, I'm trying to find what am I supposed to enable. VK bind descriptor feature was not enabled. So here, this is what I'm trying to find. Descriptor features, yes. And that's inside of device. So we have buffer the device address features, which apparently, oops, my bad, I'm pressing the wrong buttons. Like so. Physical device address features, which I do have enabled. Interesting. Why does it complain that they're not enabled? Huh? Alright, so which one is it? Extension. Okay, I don't have the with the extension. Okay, what's the difference actually between this? Let's see. I got this. Let's see. I want to know what's the difference between. Right now, the feature chain is missing the description buffer feature, which is the Vulkan says. You enable device address shader, but it's not the feature from descriptor extension. Yeah. Feature chain. You need to insert extension to pnext. So wait, I need both the extension and then your device crate should start. Must also be enabled. Yeah, that I got. Okay, but okay, why do I need both? And then I'm gonna take this thing, yes, and ext. Would it not be better to just one of them? I think I could just drop the ext at the end. I think, if I understood correctly, if you just use the normal thing, let's see, you do not need both, use only one. Confusion exists because buffer device address started as an extension and was later promoted to Vulkan core, exactly. So extension version older, yep, sometimes Kronos core version, yep, that's, we would like to use this one. So I think I will just drop the extension POSIX? Or suffix? I don't know what's it called. Vulkan promotion path works like vendor extension, Kronos cross vendor extender promoted Vulkan core extension, yes. Yes, that's what we'll do. So I will just drop the ext. Simple like that. Bind descriptor there. And we'll just remove that. I think we might have to do a few changes then when we go to here. Maybe it's not too crazy, but we'll see. Maybe it's just simple like that, because usually they are slightly different sometimes. But let's see. We're gonna remove the extension from there, and then we don't find it. So, okay, this did not work. So we're gonna go to the render Vulkan again. And what we're gonna do is that we're gonna change this to C calls again. C, what are they called? Because I don't find them. Okay, they have to be called something similar. CVK command bind descriptor for buffers. There is just the ext, I don't find the other one. How do I What is it called? Just that. That makes sense. A lot of people trip over because binding is done via extension function, not core Vulkan calls, not core Vulkan headers unless you load it manually. Since you're using extension buffer function, need is in extension functions to usually load it. Yeah, but I don't want to use that. It wasn't that clear. Minimal example. I don't wanna use the ext. There's a lot of ext's probably that could just be reduced to Let's see, render. What do we load in here anyways? Yeah, I don't load the ext, I think. Yeah, descriptor buffer. Chronos. No wait, it is the ext. I'm stupid as fuck. No want the function, the key point is entirely an extension, there's no core Vulkan. Oh my god, it's rage baiting me. Oh my god. I swear to god, okay. Jesus Christ. Well then we'll have to do it like that. And we'll just add it to... It's okay. We'll just do this. Keep on calling it ext. Like so. And... yeah. And we can go back to... I want to go back to the device. Because then we'll have to do this, like that, paste that there, and I'm gonna call it underscore ext. I can't even read that. It's so many. Whoa, that's crazy. Anyways, it's gonna be the ext. We have to then... we're gonna change this one to be... basically that. Place it there. Except...
Hello guys.
Hello
I'm gonna
there.
hear you to for like
What?
2 seconds because I'm gonna go to bed.
That's
So
crazy.
Good night, good
Hello.
night.
yes, good night. See you later,
Good night.
everyone. Yeah,
Yeah,
good night.
Good night.
You wanted to say alligator, right? Oh,
Hmm.
Planetary Sigma. What a wonderful game.
Yes, it's a wonderful game that's not running right now. But still getting
Why
this
is it
thing.
not running? Oh, also, your browser is again update.
Bro, I tried to update last time, it took 3 hours and it got 50% through. I'm not doing an update, fuck that.
Oh god. Also, Lucas, actually, after like using Linux for the last 2 years, I'm right now on Windows.
Get out of here, somebody ban this guy.
No, because I had some issues, not with Linux, but with the fucking game I was playing. Like, it just didn't want my joystick in game, even though some buttons of it worked, but not the joystick movement, and it has, for some reason, default input on the rudders for my fly shit. So, on Windows it was working. That's the whole problem I had. It wasn't even a Linux issue. The thing worked on Linux just fine. That's so weird. Like, just not in game. So I just
Wait.
decided, yeah, break it and just swap the SSDs.
Ah,
And yeah, I need to use Windows anyways for my Lua stuff I need to do, because I cannot test it on Linux for the game.
yeah.
So we'll get this done and out of my head. So yeah.
That sounds pretty fire. But yeah,
Yeah.
nah. You need to go back to Linux now. I'm telling you, back to Linux. This is unacceptable.
If I go back, I will change distro. I fucking hate Omachi. It was such a bad decision of myself to choose it. Because it just turns into bloatware. Omachi is just bloatware at that point. It was cool at
Yeah.
the beginning to have like, oh, for development, oh yeah, it's cool. But they just add a lot of AI shit. I
Yeah,
just fucking hate it.
from
And they
yeah,
have like keybinds for cloud code and shit on for Discord. And, oh my god.
yeah, I get it.
I just want to be free. I might just choose something like Debian or some shit. No, not Debian again. Oh god, I was running rather in that back then. Maybe Ubuntu or something. I'm not sure.
Yeah. Go to Linux. Arch Linux.
Yeah, Omachi is Arch Linux.
No, it's bloatware. It's not Arch Linux.
But it is Arch Linux, yeah.
No. It's not. Sorry. No.
I still don't know what to choose. That's the hard point. Like,
I think choose the thing that is
Everything's-
most convenient for whatever that you're trying to do.
Well, right now it's the Windows, but like, huh? I'm not sure. Might
No,
need to
well,
look around a bit.
Yeah.
I will definitely not want to use anything Fedora-based for the next 3 years because I made bad memories with it for like a year, and I just hate it. I don't know.
I don't think I need to do this. I'm actually like kind of like preferring to go to sleep right now. I'm just gonna push so things work. Like
Yeah.
my layout.
So, since you guys do a lot of work in Zig,
Mm-hmm.
what parts do you hate about Zig? Like, there must be something you don't really like.
Oh sure. But wait, let me see. P allocator. I don't know. Like Sig is just it's unstable. I think that's the only thing I hate about it, honestly. But
Yeah,
besides that,
true.
I don't really have much to say. It's really good.
True,
Okay, they added this IO, which apparently makes sense, but I'm still trying to learn like the basics, kind of in a way. And then they just changed how the things work. Well, it's still the same issue. It's not like there's a new issue all of a sudden. It's the same issue that I'm...
Unstable, yeah.
Yeah. So,
Yep.
yeah.
But I'm actually glad I fixed it for Z. I can finally use Z and move away from VS Code. It's the only thing that was actually holding me back besides my Lua stuff, because there's no Lua extension for Z. I like the one I need with the game natives and stuff. It's like inbuilt functions. And converting one is like absolute hell, even with AI. I tried it already. Might give it another shot in like a couple months.
Let's see.
Yeah.
Okay, Hodge loading is back. Or loading for shaders.
It's
and
back.
Hodge. Woo!
Whoopee!
Just had to free stuff at the end, but
Oh
yeah.
god, I got so many DMs. Holy shit.
Okay. No, that's gonna be it. Sadly, we didn't get the pushing of the script. Well, I'm still trying to learn how to use this without the nasty way of creating descriptor pools. And I'm pretty sure, even though it was an AI response, but I'm pretty convinced that you can do it without the damn pools. I hate them pools. Like, trying to manage these pools is like crazy. I'm like, what if I didn't have that? What if I don't have to do that? That would be crazy. Anyways, that will be it. We'll continue tomorrow. Good night, everybody. See you tomorrow. Bye bye.
Bye bye.
Does T-Chef wanna do the
Wait.
honor?
Sure. I will just
Wait.
retire. No.
Yeah, it's gone.
He's dead. Good night.
I could actually start the